All right, 6.3, we're going to talk about vectors. All right, so with vectors, we're going to talk about magnitude and direction. So our vectors are going to be a directed line segment. With our vectors, we're going to have an initial point, which is where our vector starts, and then a terminal point is where we end. So our vector has direction from the initial point to the terminal point. It's written as a vector from P to Q, like this. It kind of looks like array a little bit, but it's not quite array. It's a vector because the direction matters. So our directed line segment has an initial point and a terminal point. Its magnitude is the length. So magnitude and length mean the same thing. The magnitude symbol is kind of like this absolute value symbol, but it has 2 bars on both sides. So this is the symbol for magnitude. And it can be found using the distance formula. Two line segments or 2 directed line segments that have the same magnitude and the same direction are equivalent. So in order for 2 vectors to be equivalent, they need to have 2 things, the same magnitude and the same direction. So at the bottom of the page here, all of these vectors are equivalent because they're all going in the same direction and they're all the same length. So our vector can be written as from P to Q, like this, if we were going from point P to point Q. Or it can be noted by a lowercase bold letter. So this would be like vector U, vector V, vector W. When talking about vectors, we'll usually see like U, V, and W. So in example 1, we want to show that U and V in the figure below are equivalent. So there's 2 things we have to check to see if it's equivalent. We have to see if the magnitudes are the same. What else? The magnitude has to be the same, and what else?
The distance.
The magnitude is the distance. So that's the length where we would use the distance formula. But what else has to be the same? Direction. So let's check to see if the magnitudes are the same first. So we're going to use the distance formula. What is the distance formula? Of? X2 minus x1 squared plus y2 minus y1 squared. Perfect. So let's find the magnitude or the distance of both of our vectors. So let's start with V, the one on top. So our magnitude, which we'll write the little magnitude symbol here, would be the square root of, I'll call my initial point x1 and y1, and my terminal point x2 and y2. So x2 minus x1 would be 4 minus 1 squared, plus y2 minus y1 would be 4 minus 2 squared. So we have the square root of 3 squared plus 2 squared. So the square root of 9 plus 4, which would be the square root of 13. So our magnitude or our length of vector V would be square root 13. Let's do the same thing for vector U. So again, we're going to use our distance formula. I'll call my initial point x1 and y1, my terminal point x2 and y2. So here I have the square root of 3 minus 0 squared plus 2 minus 0 squared. So the square root of 3 squared plus 2 squared. So square root of 9 plus 4, which would be the square root of 13. Are the magnitudes the same? Yes. So I'll put a check mark there. We need the magnitudes to be the same and the direction to be the same in order to see if they are equivalent. So next we have to see if the direction's the same. to see if the direction's the same, we're going to use the slope formula. What is our slope formula?
Y2 x plus b. Oh no. Y2 minus y1 over x2 minus x1.
Y2 minus y1 over x2 minus x1. So let's find the slope of vector v. So 4 minus 2 over 4 minus 1 would be 2 over 3. Next, let's find the slope for vector u. So y2 minus y1 would be 2 minus 0 over 3 minus 0, so 2 over 3. Are the directions the same for both of them? Yes. So if our magnitude and direction is the same, are our vectors equivalent? Yes. So in order for them to be equivalent, the magnitude and the direction has to be the same. So next slide says the directed line segment whose initial point is the origin is often the most convenient representation of the set of equivalent directed line segments. This representation of the vector v is in standard position. So standard position, our initial point starts at the origin. What point is the origin? 0, 0. Awesome. So in that last question that we had, vector u started at 0, 0. So that vector is in standard position. We can write our vector in component form. If the initial point starts at 0, 0, then component form would just be whatever our terminal point is. Component form, we write with the brackets here, so these kind of arrow-shaped brackets. So notice the difference between the brackets that we put on component form versus just a normal point. If it just has normal parentheses, you're talking about a point. If it's got the brackets, we're talking about a vector. So since vector u is in standard position, it starts at 0, 0. Where it ends would be our component form. So we would say vector u is in component form, so with the little arrow brackets, would be 3, 2. So for component form, it's always terminal minus initial. So on the next slide, we have our formula for component form when our vector does not start in standard position. We would do terminal minus initial. So that's kind of what this part is saying here. It says if terminal point P1, P2, and if initial point P1, P2, and terminal point Q1, Q2, to find component form, we would do Q1 minus P1, Q2 minus P2. So terminal minus initial. When we find component form, it kind of gives us the first step of the distance formula where we did that x2 minus x1 and the y2 minus y1. So we have kind of a shortcut for the magnitude when it's in component form. So our shortcut for the magnitude is we can just square the first number and square the second number, add them together, take the square root when it's in component form. So let's look at example 2. We want to find the component form and the magnitude of vector v represented by the directed line segment that has the initial point of 4, -7 and the terminal point of -1, 5. So it's always terminal minus initial for component form. So our terminal would be -1 minus the initial, which would be 4. And then terminal minus initial, so 5 minus -7. So our component form here, what's -1 minus 4? -5. And 5 minus -7? 12. So this would be component form for vector v. Second part of this question asks us to find the magnitude. Once we find component form, we can use our shortcut for the magnitude formula. So the magnitude of v is the square root of the first number squared, so -5 squared, plus the second number squared. So we have 25 plus 144. So this would be the square root of 169. What's the square root of 169? 13, perfect. So that would be our magnitude. We can do operations with our vectors, so we can multiply by a scalar. If we have a number out front, that would change the length or the direction of our vector. So if we multiply by a scalar, if I multiplied my vector by 1/2, I'm cutting the length of it by a half. If I multiplied by 2, I'd be doubling the length of it. If I multiplied by a negative, I would change the direction of my vector. So notice how v goes this way and negative v goes in the opposite direction this way. So a negative being multiplied to your vector changes the direction of it. The initial becomes the terminal becomes the initial. We can add two vectors together. Here it gives us a picture. If I had vector u and vector v, if I added them, if I took vector v, if you put a line over vector v and dragged it to connect to vector u here, on Notability, you can just highlight it and move it up. This would now be vector u plus v. So we would start at the initial point and then end at the terminal point here. So our vector here would be u plus v. When you're adding two vectors together, you can add the first number plus the first number and the second number plus the second number. And that gives you a new vector. When you're multiplying by a scalar, that scalar just gets distributed to both numbers inside your vector. So same thing on the next page. If I had negative v, I would multiply -1 to both numbers inside my vector. Or if we had vector u minus v, you could add vector u plus negative v. You'd get the same thing. So let's do some examples. Let's look at example 3. We have vector v and vector w. We want to find 2v. So since I'm multiplying by the scalar of 2 here, I have 2 times vector v, which is -2, 5. I just distribute that 2 to both numbers on the inside, so my new vector would be -4, 10. For w minus v, I start with vector w, which is 3, 4, minus vector v, which is -2, 5. So we do the first number minus the first number. So 3 minus -2. And then the second number minus the second number. So 4 minus 5. What's 3 minus -2? 5. And 4 minus 5? -1. So our vector would be 5, -1. For C, I'm going to start with vector v, so -2, 5, plus 2w, so 2 times vector w, which is 3, 4. What do you think I'd have to do first here?
Multiply the 2 and distribute it.
Awesome, we want to distribute the 2, so this is going to turn into vector 6, 8. Then since I'm just adding it, I'm going to add the first number with the first number and the second number with the second number. So -2 plus 6. -2 plus 6, 4. And the second number with the second number, 5 plus 8, 13. So we're going to pretend that it doesn't have the answer on it. So when we add u plus v, we add the first number with the first number. So 4 plus 1 would be 5. And the second number with the second number, so 1 plus 5 would be 6. When you put your answers on WebAssign, make sure you put the brackets. But also I think for this homework, it said use it as a PDF, right? Is that what Canvas said? I think so. I think Canvas says just to do the WebAssign as a PDF. But it wants the brackets, so don't forget, if you're writing a vector in component form, put the brackets. So then when we pick our graph, we would take u and then add v to it, but our new vector, if it starts at 0, 0, it's going to end at 5, 6. We want to see which of these end at 5, 6. They all kind of do. But u would be this one, and v is this one. So if I add u to v, it would be this line here. So the fourth one. So you would just take your vector u. Our vector u was this. Add it to your vector v. So if you pick up vector u and paste it onto v, where the starting is, that would be our initial of u plus v, and then where it ends would be our terminal. So the pink line would be u plus v. So if you put it into Notability, you could draw lines over it and then just kind of highlight it and shift it, put one on top of the other. That would be your new line. For 2, we have u minus v, so we're going to use the same numbers here. So u minus v, we would do the first number minus the first number, so 4 minus 1 would be 3. And then the second number minus the second number, 1 minus 5. Which would be negative 4. So for our vector here, if we start at 0, 0, it's going to end at 3, negative 4. So a vector that starts at 0, 0 and ends at 3, negative 4 would be vector, the first one. And then for 3, we have 2 times u minus 5 times v. Let me write down what u and v are here. What would I have to do first for 3? What would we do first here? We have 2 times u, which is 4, 1, minus 5 times v, which is 1, 5. What would we have to do first? We would distribute the scalar. So number in front gets distributed to both numbers inside of our vector. So this would now be 8, 2. Minus, I'm just distributing the positive 5, and I'm going to leave it as a minus in the middle, so 5, 25. And now we can subtract. So 8 minus 5 would be 3, and then 2 minus 25 would be negative 23. Which picture do you think our vector would be? Which graph? It'd be the bottom left, because if we start at 0, then our terminal point's going to be at 3, negative 23. So our vector would look like this. Down at the bottom, we're doing the same thing. We're still doing our vector operations where we multiply by a scalar, add them together. Here our vectors just look a little bit different. So this is a different form for our vector. Standard form is with the brackets, so like component form. This is just written a little bit differently, but the first number is going to be what the coefficient in front of the I is. The second number in our component form is going to be the coefficient in front of the j. So here our vector would be 3, 7. For v, our vector would be -2, what? What'd you say? Just 1? -1. And what do you think for w? What would our vector be? 15, 0. Awesome. We don't have a j, so it would be 0. Then we would just do the vector operations from here. So 3 times v would be -2, -1, plus 2 times u would be 3, 7. What would we have to do first here? Distribute. So -6, -3, plus 6, 14. Then we add first number with the first number. So what would be the first number in my component form? Zero, perfect. And then second number with the second number, what's -3 plus 14? 11, great job. Let's do 5. So -u, so I have -3, 7, plus w, which we said was 15, 0. So we want to distribute the negative first, so we get -3, -7, and then we can add them together. First number plus the first number would be 12. Second number plus the second number would be -7. For 6, we're doing the same thing, but we are just adding 3 of them together now. So we have -4 times w, which is 15, 0, minus 3 times u, which is 3, 7, plus 2 times v, which is -2, -1. So we want to distribute first. 4 times 4 times 15 would be -60. And 4 times 0 would be 0. Here, you can distribute the 3, and then you'd be subtracting. Or if you wanted to, you could distribute the -3, and then you'd be adding. So you could do it either way. I'm going to distribute the -3 and change it to addition. So if I distribute the -3, this would be -9 and -21. And then I just changed my sign to adding. And then here I'm going to distribute the 2. So plus -4, -2. If you want to, from here, you can just add 2 of them together. We could add the first 2 together, get a new vector, and then add the third one to it. Or you could add all 3 at the same time. So the first number with the first number with the first number. -60 plus -9 plus -4 would be what? -73. And then we have 0 minus 21 minus 2, which would be what? -23. Awesome. Any questions here? Sometimes with our vectors, we might have 3 numbers in it. The same rules apply. You just add the first number with the first number, second number with the second number, third number with the third number. If it's written in this form here with the I and j, it would be I, j, k. So I could have vector, we'll call it vector v. That would be I plus 2j plus 3k. So this would be vector 1, 2, 3. So your vector could have 3 numbers in it.